Okay, so I'm gonna assume that people may show up after a while, like they sometimes do. But I am gonna go ahead and get started. Turn some light on this. And this is 9.4. All right, 9.4, graphs of quadratic equations. Okay. All right, quadratic equations, once again, are equations of the form ax squared plus bx plus c is equal to 0. We've been looking at those for the last couple of days. The simplest or most basic is y equal to x squared. To graph this, we're going to plot a series of points x, y, where we're going to let x be, let's start at like a -3, and then do a -1, a 0, a 1, and a 3. Just so there's some sort of symmetry back and forth here. So if I let x equal -3, then y would be a -3 squared. That's a 9. If I let x be a -1, then y would equal that -1 squared. That's a 1. We have a 0, 0. 1 squared is 1, and 3 squared is 9. This gives us 5 points. The first point being a -3, 9. The second point, -1, 1. A 0, 0. A 1, 1. And a 3, 9. When I graph these points, -3, 9, -1, 1, 0, 0, 1, 1, and 3, 9. You see that this particular graph is not a straight line. This graph is something called a parabola. Questions so far? Okay. Do you remember parabola at all, Summer? Some people do say parabola. Yeah, people say it both ways, parabola, parabola. Yeah, that sounds about right. That does sound about right. Okay, so there are several qualities or characteristics of a parabola. Okay, the first one I want to talk about is the direction. Some parabolas, like the one we just saw, open up. Some parabolas open down. If a parabola opens up, this means that our leading A was greater than 0. And if our parabola opens down, this means that our leading A was less than 0. So if a parabola opens up, then it starts with like 4x squared or 2x squared or just an x squared. If our parabola opens down, then it's going to be a negative something. So this will look like an ax squared plus bx plus c, where a is greater than 0. If it opens down, then it would be a negative ax squared plus bx plus c. Second characteristic I want to talk about are the intercepts. A is negative. That's just neg. But last one didn't go so well. All right, so just a couple of reminders about your intercepts. Your x and y intercepts are where you cross, where the graph of the parabola parabola crosses the x-axis and where it crosses the y-axis. So if I'm looking at a graph like this, we would have an x-intercept where it crosses the x-axis and a y-intercept where it crosses the y-axis. So while all of these that I'm going to draw are going to face up, the same can happen if the parabola is switched and goes down, opens down. So in this first case, there are two x-intercepts and one y-intercept. There can also be just a singular x-intercept and a singular y-intercept. So here's an example where we just have one x-intercept and it is also the y-intercept. Now, this will also occur if the parabola is like moved to the left or to the right. So here's another parabola that has one x-intercept and one y-intercept. They're not the same in this one, but and then you can have a case where you don't have any x-intercepts. But you still have a y-intercept. There are several different scenarios here. All right, the third thing we want to talk about whoops, I'm off the line, is the symmetry of the parabola. You've probably noticed as I was drawing all these, and maybe you noticed with the first one, that when you have a parabola, there is often, or there is always, I should say always, what's known as the axis of symmetry. And so here's a parabola. This one, your axis of symmetry is right here. If I look straight up and down, there's a line through the middle where I could fold, essentially fold the parabola in half, and it splits it down the middle. This is known as your axis of symmetry. And in this case, it is at x is equal to 0. It never moves off the y-axis, so our axis of symmetry would be at x is equal to 0. Here I have a second example, and you can see the axis of symmetry gets moved. The axis of symmetry is now through the sort of top here, and now that axis of symmetry is at x is equal to -2. It doesn't matter how I create this parabola. If it is a parabola, it will have an axis of symmetry. Well, it's not exactly where I wanted it, but that's okay. We got it. One-ish. Questions about the axis of symmetry, Summer? Okay. This brings us to our last piece, which is the last characteristic I want to talk about, which is the vertex, and then we're going to graph. The vertex is the parabola, is the turning point of the parabola. So if I look at the 3 above, this turning point right here is your vertex, where the parabola switches. And notice that the axis of symmetry will go through that vertex. All right. We use all of these characteristics to graph a parabola. Now, I know this is going to seem a little bit crazy, but this does work out faster than creating a table. It seems like more work, but once you recognize the characteristics, it's much faster to graph. All right, so we want to graph, let's see, let's graph x squared plus 6x plus 8. All right, so we want to graph x squared plus 6x plus 8 is equal to y using the characteristics of the parabola. So the first thing we're going to look at is which way does it open? Now, since we have x squared plus 6x plus 8, my leading coefficient is positive. So that means that this will open up. Remember, if your A is positive, it's going to open up. So I now know which direction it's going to go. I'm going to find the x-intercepts, and I'm going to find the y-intercepts. In order to find the x-intercepts, it's the same thing we do for a line. We let y equal 0. If we let y equal 0, we have x squared plus 6x plus 8 is equal to 0. We want to use one of our many methods to solve for x. We can factor it, we can complete the square, we can use quadratic. Any of those are fine. I usually recommend that we look at whether or not we can factor. Are there two numbers that when multiplied give you 8 and when added give you 6? So we have an x plus 4, x plus 2. Solving the mini equations, x would be a -2 and a -4. Our x-intercepts will be at -2, 0 and -4, 0. Oops, this isn't 3 yet. Y-intercept is super easy. We let x equal 0. If I let my x values equal 0, 0 plus 0 plus 8 would be y, so 8 is my y. And I have a point at 0, 8. Third, we find the vertex and the axis of symmetry. This is the new bit in terms of things we haven't done yet. Here's what you need to know. The vertex is at x equal the opposite of b over 2a for ax squared plus bx plus c. So since my x value, the axis, the vertex, I'm going to let my x be the opposite of b. That's going to be a negative 6 over 2 times 1. So that's a negative 6 over 2, or negative 3. Then the y value is a negative 3 squared plus 6 times the negative 3 plus 8. I think I get negative 1. Right? Negative 3 squared is 9. Minus 18 is negative 9. Yep. Into the x squared plus 6x plus 8. So this gives me a point at negative 3, negative 1 that I know is the vertex. This should be enough to graph. Now, you can put a couple more points in. You can check a couple more xy's if you want to be sure. That's what the text recommends. But really, you should have it all right here. So let's see if we can graph this one. So I'm going in to graph this one. Sorry, I had to turn the page. No, I am not. I mean, you can do a couple of things to survive. If you have a printer, you can just Google graph paper and print off a sheet or two. Yeah. But you really should just be able to draw a quick graph without being too exact. I'm not going to be horribly picky because most of your work should be the algebra and not the graph itself. Does that make sense? Because we just found out you had a vertex at negative 3, negative 1. So this should be my vertex at negative 3, negative 1. I had x-intercepts at negative 4, 0 and negative 2, 0. And there's a y-intercept at 0, 8. The vertex is like the turning point. It's the starting point. Your axis of symmetry will go through the vertex. Negative 4, 0 was 1. Negative 2, 0 was the other. Do you see how when you plot those 2 points, there's symmetry there? Yeah. Our y-intercept was at 0, 8. So since 0, 8 is 3 units to the right of that axis of symmetry, I know that 3 units to the left should be another point. So even though I didn't calculate that point out, the axis of symmetry will tell me it's there. And then that should be enough to draw a quick graph. Can we try a couple more just to see how they go? All right. Okay, so let's graph y equals a negative 2x squared. Okay. Plus 4x plus 2 using the characteristics. Okay. First characteristic is which way it opens. This one is going to open up or down. Yep. How did I know? It was a negative 2x squared. That negative opens down. We're going to find the x-intercepts. This uses factoring or quadratic. We're going to let y equal 0. So I'm going to have 0 is a negative 2x squared plus 4x plus 2. Is it? Lots of activity. Are they heading home for the end of the term? Well, you probably have more people than UWL there too. Okay, so given a negative 2x squared plus 4x plus 2, I'm going to factor out a 2, but I'm also going to pull out that negative. Good call. Oh, this should have been a negative 2. I'm sorry, I wrote it down wrong. So that's going to be a plus. That's helpful. There we go. Now, x squared minus 2x plus 1, do you recognize that one? Oh, I'm sorry. Of course you can. No, I wouldn't use the A times C here. Because if we've pulled out, I mean, you could, I suppose. If we've pulled out the -2, you should just have x squared minus 2x plus 1. This, what two numbers multiply to give you a +1, but when you add them, you'll get a -2. Good. So this works out to be a perfect square trinomial. X squared minus 1x minus 1x plus 1. Oh, okay. Sorry, I misunderstood. So now here we can use our minis. Either -2 is equal to 0, which isn't going to happen, or x is equal to 1 and x is equal to 1. Do you see how we got the same x value twice? This is sometimes called, well, it's called a double root, sometimes affectionately called a double tap, or a turn and burn. I'll show you why it's called a turn and burn in just a second here. Now, that solves our x-intercepts. Our y-intercepts, we let x equal 0. And if we let x equal 0, then y would equal -2 times 0 squared plus 4 times 0 minus 2. So we're going to get a y-intercept at 0, -2. Our vertex or axis of symmetry is found when we let x equal the opposite of b over 2a. So if we look at our original, b would be 4. So we're going to have the opposite of 4 over 2 times that -2. So I'm getting a -4 over 4, which is 1. And now I'm going to let y equal a -2 times 1 squared plus 4 times 1 minus 2. And so I'm getting the 1, 0. I know that this opens down, so I'm putting my graph a little bit higher, so I've got some room to work below. Okay, it opens down. I have an x-intercept at 1, 0. I have a y-intercept at 0, -2. My vertex / axis of symmetry is at 1, 0. And my x-intercept is 1, 0. So what that means is that I can use this axis of symmetry for this point at 0, -2. You see how it's 1 to the left? That means I'll have a second point 1 to the right. And these 3 points are enough to draw the parabola. Doesn't need to be perfect, just needs to show it. All right. Do you remember how we called this a double root? This is a double root, sometimes called a turn and burn, because the parabola just touches that point and then turns around. So sometimes we affectionately refer to those as double roots as turn and burns. Because it is a turn and burn, I would know through practice that that also makes it the vertex, because the only place a parabola turns is at the vertex. So that is super helpful there. Okay. Questions? Okay. Okay. I just want to do one more thing here. Now that we've done through those. And that is that you can get some visual cues to the number of solutions from your graphs. All right. First of all, if you are given the graph of a parabola and there are no x-intercepts, that means there are no solutions to the equation. It's not factorable. You're going to get no real solutions, so quadratic formula would give you imaginary answers. Not irrational, but imaginary. You'd have a negative under the square root. Visual cues, C-U-E-S. The visual cues are all about the x-intercepts. So if there are no x-intercepts, there are no solutions to the equation. And you've already seen this one. If there is just one x-intercept, then there is one solution to the equation. And if there are two x-intercepts, then there are two solutions. Those x-intercepts indicate where the solution is. So wherever that parabola crosses that x-intercept, that is a solution. I just want to look at a couple of graphs here so that you can see. All right, so if I'm looking at negative or at problem 31 here, and they've got the graph in blue, do you see how it has x-intercepts at 1, 0, and 4, 0? That tells me that the solutions to this equation are x equal 1 and x equal 4. Because those are the two values of x that have to give me zeros. In problem number 32, I've got a turn and burn at 1, 0. So 1 is the only solution to this equation. A positive 1 is going to give me a 0. So the solution to this equation has to be the 1. And if, for any reason, you get a graph like 49 or 50. Do you see how those don't touch the x-axis? There are no real solutions to these equations. There's no x value that will work. Not a real number anyway. If they don't touch, there's no solution, no real number solution. Yep, if it doesn't touch the x-axis, there's no real solutions to that equation. Any last minute questions, Summer? Okay. Yep, it should be. Okay.